Welcome, sixth grade scholars. Thank you for attending. We're going to be talking about integer operations today. Our objective will be, I will add, subtract, multiply, and divide integers using models, illustration, and integer rules. I will also be able to solve integer problems in practical situations. What are integers? Take about 30 seconds to write down the definition of integers and give me some examples and non-examples. Great job. Integers are positive and negative whole numbers, including 0. 0 is not a negative nor a positive number. Examples of integers are as follows. Yours may be different, but that's okay. The one thing they have in common is that they are all whole numbers. You may look at 2 to the 4th power, but once I simplify this expression, it gives me an answer of 16. And therefore, I can make this a positive integer. Some non-integers as listed here. First one you may recognize, the estimation of pi. This is not an integer. What do they all have in common? They have that decimal value behind it. Okay, so therefore these are not integers. These are rational numbers. So if a number doesn't have a negative sign in front, we're going to assume it is a positive number. The additive inverse states that the sum of a number and its opposite is always 0. Now, I'm sure you pretty much remember the word zero pair because those things, when we get them together, they kind of cancel each other out. So we can kind of get rid of them. Why? Because it gives me that additive inverse. There are clues that give you an indication of whether a word or whether a number is a positive or a negative. These are some of the examples. There are plenty of more. I'm sure you probably can come up with some. But if you think about a word and its antonym, that gives us a positive and a negative. So these are just a few examples. We think about these in real world situations, increase and decrease. We increase the temperature, then it decreases to get colder. So we can think about it in those types of terms. So let's say we have no money for lunch, so we borrow $4 from a friend. After school, we receive $7 as an allowance. The next day at school, we pay back our friend. How much do we have left? By using a number line, the problem can be represented as shown below. We want to start at 0 unless otherwise indicated. So we're going to start at 0, then we're going to move to the left because borrowing means I'm having a -4, which means I'm going to go to my left. But then it says I'm going to get $7 back in allowance. So that's a positive 7. So I'm going to jump 7 interval spaces, 1 interval space at a time, 7 times to the right. That lands me at a positive 3. So my answer would give me, I have $3 left once I finish this. I can also use counters to represent this exact same problem. Whenever you're using some types of counters or illustrations, please make sure you pay attention to the key. In this case, the key represents the yellow represents a positive 1, and the red counter represents a -1. So I have the -4, I have 4 4 red chips, and then I have 7 yellow chips. What's indicated in the dotted lines is my what? You got it, 0 pair. So in that 0 pair, I can get rid of those. And once I get rid of all 4 sets of 0 pairs, I have a positive 3 left. It's the same with the illustration below. Just use hearts and triangles. You can use any type of illustration you like as long as you think about what your key is going to be. Again, 0 pair for every heart, I can get rid of a triangle, and what will be left is a positive 3. I rewrote this a little bit. I have 7 plus -4. Can you tell me what property allows me to do this without changing my sum? You got it. The commutative property of addition. So integers with subtraction can be a little difficult, but this one right here is very simple. If we start with a -5, we have -5 tokens, and the problem tells me I need to subtract -3, well, I can do that because I have them there. So once I do that, what's left is a -2. Very simple. The signs are the same, no problem. But when I get to these ones that the signs are different or unlike in subtraction, then I want to think about, and I want to go through the thought process. So if I have 5 positive counters and it tells me I'm going to subtract -3, well, I don't have -3 to subtract at this time, but my 0 pairs allow me to place those in on the mat so that I can get rid of this -3. So I'm going to place 3 sets of 0 pairs on the mat as indicated below. And now I can subtract a -3 from my mat. But what is left on my mat, if I count them all up, are 8 positive counters. Multiplication and division is a little easier, but I'm thinking about just multiplying and dividing by the absolute values of the numbers that I'm looking for to get the product or the quotient to. If my signs are alike, my answer is always positive. If my signs are unlike, my answer is always negative. So this example is 3 times -4, unlike signs, my answer is -12. 3 times 4 is 12, unlike, answer is negative. So this just have, in the pictorial representation, 3 sets of -4. I have 3 sets, horizontal, 3 sets of that -4. And -12 chips on my mat. Here you have our anchor chart, and I would like for you to write down the rules for your operations with integers if you need to. So you can pause the video while you write these down. So again, this is a review, so you may not need to do that. But if you do need to pause it, go ahead and pause the video, write it down in your notebook, and once you're done, unpause and we will continue. So let's take a quick brain break. I want you to touch your left ear with your right hand, and at the same time, you're going to touch your nose. I'm going to touch your nose with your left hand. You want to try to do this. We're going to do it like 4 times. So let's switch. 1 at the same time, 2, and 3, and 4. I can't find my nose. I found everything else. Can't find my nose. Then just close your eyes and just take in a breath. Breathe. Deep breath in, deep breath out. Deep breath in, deep breath out. Shake it out. Great job. Let's go ahead and get started again. So just going back to our objective of the day, keeping us on track, we're going to add, subtract, multiply, and divide integers using models, illustrations, and integer rules, and solve integer problems in practical situations. So what we're going to be using, we're going to be looking at our Learning from Home resource, and we're going to be looking at pages 30 through 34. In the package, there are vocabulary words, there are these great illustrations and problems in which we're going to be reviewing as we continue throughout the lessons. So I'm going to identify each true statement. -9 minus 5 is equal to -4. I can draw it out. You can use the counters, you can use the number line, or you can just think about the integer rules, whichever is easier for you. I'm going to go ahead and look at the rules. So -9 minus 5 is equal to -4. I want to change it to an addition problem. So -9 plus a -5 like signs, answer is -14. Answer is incorrect. So here I'm going to go to the next one. -12 plus 13 is equal to 1. Unlike signs, the rule tells me to subtract. 13 minus 12 is equal to 1. Absolute value, highest absolute value is positive. Therefore, my answer to this one is correct. I might have would have just done this one in my head. So again, think about, ways that you can make this easier for you without actually having to go through all of your rules and steps. So 4 times -7 is equal to -28. Again, the rule for multiplying and dividing, ignore the signs, multiply or divide, and look at your signs. So in here, I have 4 times 7, which is 28. They're unlike. It should be negative. My answer is negative. This is correct. 4 times 3 is equal to +12. Well, first I look at my signs. These are unlike. My answer should be negative. I don't even need to go any further. That is incorrect. -27 divided by -3 is equal to 9. Like signs, so my answer should be positive. Is 27 divided by 3 9? Yes, it is. That is correct. 10 divided by 5. Unlike signs, 10 divided by negative 5. I have unlike signs, so it should be a negative, and 10 divided by 5 is 2. Negative 2 is my answer. That is correct. 10 minus negative 4 is equal to negative 14. Subtraction problem, so I want to change it to an addition problem. So 10 plus a positive 4. 10 plus 4 is 14. This answer is incorrect. And then I have negative 5 times negative 6. Like signs, my answer should be positive. 5 times 6 is 30. Awesome job. So identify each statement that is true. You want to go ahead and either circle or you highlight all of your correct answers, but you don't want to select your incorrect answers, because when you do that, the whole thing will be wrong. So always think about doing all the problems and then circling or highlighting those ones that are correct, as we did just in the previous slide. So now it's your turn. Which of the following equations is not true? Again, go through each one, A, B, C, and D. Write them out on your paper. Take your time, pause the video, and once you are done, restart. Great job. Hopefully you had your answer of A. And here's your reason. I just rewrote it and changed all of my subtraction problems to addition problems. And then I found the solutions that way. And then I put false, true, true, and true. Therefore, the only one that was false was A. You could have used your number line. You could have used counters. Totally up to you. You could just kind of intuitively thought about which one is correct. Perfect. So which equation does the model represent? Again, always paying attention to your key. Your key is right here to your left. Positive is equal to 1. Yellow is equal to 1. Red is equal to negative 1. So it represents a negative 2 plus a positive 3. And I have the 0 pair here. I have a 0 pair here. And what will be left on my mat is a positive 1. Good job. So your turn. I want you to see if you can do this one on your own. So just think about this practical problem and visualize yourself doing this practical problem. Maria enters an elevator on the 3rd floor and rides it up 6 floors. She then rides the elevator down 3 floors and then back up 2 floors. When she finally exits the elevator, on what floor is she? Again, pause the video, use a number line and the expression, and see if you get the same answer for them both. Once you're ready, unpause and we will see if we have the same answer. So up top, I did it first as an expression. Step 1, I started on the 3rd floor, so I didn't start with 0. I'm starting with 3. I write it up 6, so 3 plus 6 equals 9. But then I go down 3 floors, so that represents a negative 3. So I end up on the 6th floor, but then I ride it back up 2 more floors. So I end up on floor number 8. Using a number line, I can do the same exact thing. Start on the 3, I'm going to go to the right 6 intervals to the right and end up on a 9. But then I'm going to go to the left 3 intervals, end up on a positive 6, and then again to the right, end up on a positive 8. Great job. So your independent practice, which again is found in our practice notes, you're going to do number 3, number 4, and number 5. And as indicated, you want to look at each one of these problems and you want to determine whether the number is representing a positive or whether it is representing a negative, and what operation you're going to be using to solve your expression. Once you're done with these 3 problems, you're going to go ahead and go to your Desmos account. So I think we can almost positively say that we have met our objective of the day, which is I will be able to add, subtract, multiply, and divide integers using models, illustrations, and integer rules. I will be able to solve integer problems in practical situations. I will be giving you the answers for your independent practice on the next day. So look forward to seeing you on that day as well. And again, do not forget to spend about 10 to 15 minutes practicing in your Dreambox account. I thank you. You all done. You did a great job. Tomorrow we will be simplifying expressions using order of operations. See you soon.